Alright, let's talk a bit about wireless. Some of this was discussed when we were talking about the different types of media, the network media video. Went through some of the specifics on wireless, such as the different types. There was 802.11a, B, G, N, AC, and so on. And then each of those use a different frequency range. For example, we have 5 gigahertz, 2.4 for all of those, optional 5 gigahertz for N, and AC using both 5, 2.4, and 60. So we went through some of that. If you want to go through in detail on that again, go check out the network media video, and we go through some of the more details on that. But what we're going to do is talk about some of the other pieces of wireless and what you need to make that happen, besides the actual media itself, the frequencies. So some of the devices you need we've discussed. So in order to connect wireless, we're going to need some sort of wireless network interface card. You need some sort of NIC. With a laptop nowadays, those are built in. You might need, for an older device, you might need a little card with an antenna that comes off of it. If it's on a desktop, you'll need some sort of card that connects into your board, your motherboard, and it's got a little antenna that comes off. Pretty much every device has it built in now except for desktops, so as long as you have something newer, you'll have a NIC built into that. We also need some sort of wireless router, so or access point, I should say. For home use, you're going to use most likely a wireless router, which combines the access point functionality, router functionality, sometimes switch functionality. Takes care of many hats, firewalling, often provided by your ISP. It's going to be some sort of a Action Tech device or SMC device or something like that. Linksys, Netgear, Belkin, so many other companies out there, they make all-in-one devices as well. If you are in some sort of a business environment, you're most likely going to use, as I mentioned before, a wireless access point, also referred to a WAP or an AP. And there are different kinds of those. So we have autonomous APs, and we have ones that are controlled by controllers. An autonomous AP is similar to the configuration method of a wireless router, where configuration is local. Each device has to be configured individually. It's not very scalable. If you're in a small business where they they have like 3 or 4 access points, then that's probably fine. But once you get into a larger environment, that's not sustainable. So what you'll switch over to is a controller based access point, and you have 2.5 flavors of those as well. You have ones that are controlled using a controller server, and then there are ones that automatically choose a controller out of the existing access points. Some of those are called, for example, Aruba has ones called instant access points, or and the idea with these, where they act in such a manner that they choose, we'll just put this down, choose one as controller. So one of the access points acts as an actual controller, and that has some pros and cons. The pros being you don't have to have individual controller servers out there. The cons being that the access point could get overloaded with what kind of traffic it has to deal with and management duties it has to do. And that's up to you to decide on your size of your wireless rollout and how you design your wireless and the amount of traffic you're going to have to deal with. All sorts of different variables for that, and then each firmware, they improve that sort of functionality. There's also ones such as AeroHive has like a hive type hive mind functionality where they all act as a controller. And there's others out there that do like a similar function as that, where they all kind of share that duty. So out of controller you have those three essential options. The original type is essentially this controller server model, which before the acquisition of Meraki, Cisco purchased a company called Meraki, which they actually offer a fourth option really, which is a cloud-based controller, which is still a controller, but it's not physical to your location. All the devices communicate out to the cloud, and the cloud has the controller software running, and you don't have to worry about it. But before Cisco bought Meraki, they did primarily that controller model where it was all one physical server. Depending on where you needed wireless access, you'd have a physical server there at each location, and then your cluster of access points would all talk back to this main controller server. As far as antennas go, there are a couple different types of antennas, the majority of them being omnidirectional. If you buy any sort of basic access point, it's going to be some sort of omnidirectional antenna system. Some of the fancier ones have a bunch of antennas that come off the back, which gives you a little bit more flexibility on how the signal is sent. So if this is like your router, some of them are just built in, you don't see the antennas at all. And the majority of them, this is something important to remember, especially with the wireless access points designed for business, is they're designed, at least these kinds, are designed to be installed on the ceiling, majority of them. And with that, you'll have your drop ceiling, and then you'll have a bunch of supports for your drop ceiling, and then all your cables. This is like a cross section. So all your cables will be probably laying on the drop ceiling, where they're not supposed to be. And then you'll have fluorescent lights and all that fun stuff we were talking about. And underneath the drop ceiling, where normal people walk about, you'll have a hole cut, and then you'll have an access point mounted off of that ceiling. And often that's on some sort of channel. If you look at a drop ceiling, you'll have metal channels that are in between the different drop ceiling pieces. Often they will snap onto that metal channel to make your life easy for mounting. But the access point will have like a metal base where all the electronics are attached to, kind of like on a case for a computer, like a desktop. You have that backing where everything screws onto the case. Similar idea here. You have a metal backing to the access point. All the boards and stuff are in here, and then the antennas are internal, usually towards the surface. And then you have like venting and LEDs and stuff that are on the top. So it'll face downwards, and with that, the signal will spread out in a downwards and horizontal fashion. It won't go up necessarily, or if it does go up, it'll be minimal. So that's something to consider when you're deploying that. Make sure you orient your access points appropriately. Unless you purchase specific access points with specific types of antennas. So if you buy the basic type of access point, most likely it's an omnidirectional antenna with this backing plate that kind of forces it in a directional mode, but it's not necessarily a perfect directional antenna. So since I mentioned that, there's also, of course, directional antennas, which actually look kind of like this sometimes. Sometimes it's some sort of like dish type system. If you have a real fancy need, you can get like looks like a satellite dish type design. You can get all sorts of different ones that have all sorts of different looks. Directional is used majority-wise. I'd say the omnidirectional are used indoors the most, and they'll have sometimes this like metal backing where it kind of directs it in some fashion, but they're not really directional. The directional antennas are used majority for connecting between direct to locations. So, for example, you have building A and building B, and you don't have some sort of fiber connection underground or something to them. You could use microwave communications between the two, and you can send wireless communication between them. That's one option. You can also do it just to spread directional traffic to some sort of courtyard or something like that. Say you have building A again, and you put up this directional antenna. This is like the world's worst directional antenna. And you have some sort of field or something you want to provide access to. You know, you could like spray downwards into this area or something like that. But then you'd have to consider the clients here, because the clients are going to be omnidirectional, so they may not reach back to where you need access to be. So most of the time it's used for building-to-building type communications. And based off of that, there's also a third type, which really is a directional antenna, but it's a special kind, is a Yagi antenna, often used for television reception. You've probably seen them before. They look like this. They get smaller and smaller, and then there's like a main bar. And this is like the top-down view. Often they'll just be sideways like that, and the beams coming off will look like this, and then it'll point in some direction, and then you'll have like a support post or something like that that connects to the roof. And these are meant to direct the signal in that direction of the smaller crossbars. So this is like the back of the signal, and then it will direct this direction. So these are specialized for transmission and reception. You'll often see them as TV antennas. A lot of amateur radio operators use them to direct their traffic in a certain way, and can also be used for communications like this. There's a couple different modes that are available for communications, depending on what kind of situation you're in. The basic kind is ad hoc mode, and that is really client to client. So technically you could have some sort of laptop, and then you could have another laptop, and this is available in pretty much all operating systems. You could create a network between these two using ad hoc mode. So if you wanted to share files or something, you wouldn't necessarily need to connect to someone else's network. You could actually make your own little network with ad hoc mode and communicate between the two. It's not commonly used though, especially because it's a security concern if you're allowing other people to directly connect to your device. Yeah, I haven't seen it used quite often. For infrastructure side of configuration, there's two different types of infrastructure modes. And within the configuration interfaces for devices, you'll see it actually referred to as infrastructure mode most often. And within infrastructure mode, there are two types. There is basic service set, and there is extended. And with these two sets, they're actually very similar. So basic service set is you have one AP. That's basically it. So you have a single access point, all the clients connect into it. So this is most common in houses or really small offices. You have one access point, you know, here's your house, you got 2 floors, you have a roof, and you have some sort of access point here. It covers just enough to get to the walls of your house, maybe a little bit beyond, so everyone connects to it and everything works fine. Extended service set is more than one access point. And commonly, what happens here with extended service set is you'll have one shared, or they could be serving up multiple SSIDs, but usually it's for a basic idea. There's one SSID that is sent. So service set identifier, that is the name of your network. So SSID is the name of your Wi-Fi network. So these multiple access points will be all displaying the same SSID. So if we have a couple access points here, they would all be sending out and broadcasting whatever we want to call it, like home could be my SSID. When you go to large businesses or schools or something like that, and they always have that same network that you can connect to no matter where you are, that's an extended service set. There's always the same SSID that's being sent out. But with this kind of setup, you're going to want to take into consideration the channels that are being used. So in this setup, you're using the same SSID, but you'll want to make sure that they're using different channels, and we'll talk about channels in just a minute. But what you'll want to have happen is that not for these adjacent access points to step on each other's toes and use the same channel. So theoretically you could have channel 1 and channel 6 and channel 10 and channel 1. That way the range of these access points will overlap. So this access point, we'll use a different color. This access point's the green access point. This one might make its maximum range might be approximately something like that. So it overlaps with the first one. He's running on channel 1. The second one will have a maximum range of something like this. He's using channel 10. Your next one, cyan, it has a maximum range of something like this, and he's using channel 6. And then our last one, the red one, is again using channel 1, and his maximum range is something like that, but it does not connect, does not touch the range of that other access point that's on channel 1. So that way the communications that are on this device do not overlap and cause collisions on this device. And we'll talk about the different channel options in a minute. But that's the idea with extended service set. You have one SSID but different channels. And that allows for easy communications as you're roaming around, basically. So if you're in a very large business or large building or something like that, you're going to have, you need to have multiple access points, especially when we were talking about the faster speeds. Remember, we're talking about beyond N, we have AC and these fancier specifications that give faster and faster speeds, but they're using higher and higher frequencies. And with those higher frequencies, you have less penetration between walls. So you need more access points to cover the same area because the range of those access points is less due to the nature of the frequency they're using. So the requirements for more and more access points is increasing due to this. So this sort of situation is very common and becoming even more so. I mentioned wireless uses CCNA, since I was talking about collisions. It uses CCNA, and you can go back to our video about that and how that differs from CCNA-CD. So it does more of a waiting period than a detection of the collision because of the nature of wireless. And let me blank this out and we'll make another page. There's a number of management frames used in wireless that are used to connect to an access point. Some of those management frames are such as Discover. We have Authenticate. And then there's Associate. As far as Associate goes, and we'll talk about Authenticate and such as well. But as far as Associate goes, there's a number of parameters in there which kind of tie into what we were just discussing with the SSID and things like that. The Associate will have the SSID name. It's going to have what password is involved. Network mode, is this 802.11a, b, g, n, etc. And what channel settings. So there's that channel cropping up again. As far as channels go, there are 11 in North America, and there are 13 in Europe and elsewhere. And it really depends on the agencies involved in those, wherever you may be. But in North America we have 11, so that's why I was mentioning some of those channel numbers in the last page. You have 13 in Europe. So the 11 in North America are non-overlapping. Well, 3 of the 11 are non-overlapping, I should say. So the way these work are, you have, let me see if I have enough room here. 1, 2, 3, 4. Okay. The way these frequencies, these channels work, the frequencies will kind of increase until they hit their peak at that channel number, and then they'll decrease. And then they'll increase and decrease. And I drew that terribly, but the idea is channels 1, 6, and 11 do not overlap. So if you send traffic on channel 11, it will in no way cause issues on channel 6, and will in no way cause issues on channel 1. Problem with that is the default channel selection for basically every device that's ever shipped. So if you're in a high density neighborhood in your home, or your office building has a ton of smaller organizations that have released out office space, is a very good chance that these channels are completely saturated and other people have not changed their channel settings, so these will most likely be very, very busy. You may have like 6 SSIDs over here, there might be 5 over here, there's going to be like another 5 over on this channel, and they're just completely saturated. You would not want to use them. So what you can do instead is change your channels. So one thing I would suggest is, if you're going to deploy wireless, and take a look at your existing area, do an audit of what's available for channel usage in your environment. Take a look at the spectrum usage as well. You can actually get pretty cheap little Wi-Fi 2.4, 5 gigahertz spectrum analyzers. And there's one there's called like the Y-Spy, and there's other ones that just like plug into a laptop and are easy to use. But it'll give you a real nice breakdown of not just the channel usage, but the actual frequency usage. Because remember, we were talking about some of those issues that you'll run into, like microwaves and such in the area. Those obviously won't show up as a data channel, but they'll show up as interference in the frequency. So do a site survey and determine what's currently in use in your area before you start deploying. There's another way of doing it that's kind of the poor man's version. If you can't get an analyzer, which sometimes are in the 100 to a couple hundred range, there's a nice application called Insider, which is made by a company called MetaGeek, and they've just changed their page, so I'm not sure how to get to the free one anymore, but there was a free version. So if you look up Insider free, downloads.com still has it, and it has a nice little interface that will show you at least it won't give you the microwave information of the actual channel, of the actual frequency usage. You'll still need to use a spectrum analyzer to do that, but it gives you at least the data channels in use by other people's access points. So you can see here, here's channel 1 that's quite used. Here's a whole bunch of stuff on channel 6 in this area. Here's a whole bunch of stuff on channel 11. You can see all the lines for the different access points that are in use. So that's a good way of determining what's going on in the surrounding area, so that you don't make a mistake and put your access point in the exact same channels that are currently saturated. What I often do is I'll put my channels on something like channel 3 or channel 8, so that I'll put it over here. So I might not, I might overlap with these other channels, but the maximum of my channel is on this tail end of the others that don't overlap. So if there's a ton of people on 1, 6, and 11, I may use 3 or 4 or 7 or 8 or something like that, or 8 or 9, and that way my peak of my channel frequency is somewhere in that lesser used area of the band. So you have to kind of fiddle with that. Since we're talking about channels, there's a couple different channel management methods, and we'll just make a new one here. There is direct sequence spread spectrum, DSSS. Direct sequence spread spectrum, which spreads the signal over a larger frequency and reducing interference. The signal is multiplied by a known code, and the receiver knows the same code, so it can reconstruct the signal. And this is the older method. It's used by 802.11b, and other things like cordless phones. It's kind of a simple method of doing it, so the less expensive equipment will use this. Cordless phones, cellular even. GPS does this. There's also frequency hopping spread spectrum, so that's FHSS, and they keep coming out with different methods for each of these new specs. They come out with new ways of trying to use the channels and make them the most efficient, and that's how we keep getting these faster speeds and greater reliability and such. So FHSS is similar to DHSS or DSSS, but rapidly changes the frequency. The receiving node will have to know what channel to listen on, so that's kind of the downside there. And this is used by things like walkie-talkies, 900 megahertz phones. Bluetooth does this. There's also the newer method, which is was actually one of the original methods too, but then it came back again. This is orthogonal frequency division multiplexing. Orthogonal frequency division multiplexing, OFDM. And this one's pretty popular. It creates subchannels. That are orthogonal to each other. So that way it allows overlapping, but they can be mathematically determined, and is easily created and received. So it's very efficient. And this is used by 802.11a, G, N, AC, etc. So this is really the most popular one right now. As for specific of these higher ones, when we talk about this channel usage and such, usually the channel size is 20 megahertz. So if you look at those different channels, you know, those different bubbles of channels, they'll be 20 megahertz in size. One thing that N and AC and so on, they can do these nice things such as bonding the two channels together, and they can make a 40 megahertz channel. And that allows for greater bandwidth possibilities and reliability and such. You can do more with that 40 megahertz, but you have these wider channels to deal with then. So lastly, let's talk about some security. So security-wise on Wi-Fi is an issue, because when you send your traffic out onto the radio waves, it's as if someone else was sitting on your wired network. They can see everything that's happening. There's no security there by nature whatsoever. It's just, here's some bits on the wire. They go out to the radio waves. Anyone with a similar radio can listen to it and see what you're saying. So there's 3 different kinds of basic security, and then within that there's many versions of it. But the most basic version was open. Open is no security. It was very common years ago to ship out home equipment and such that just made a wireless network that was open. And a lot of small businesses still do that. And this is highly insecure. There's no security whatsoever. And if you have your local network on open, and if you're a small business or something like that, you are open to so many liabilities. It's just crazy. If you run a small business, for example, and this is something I harp on because no one listens, and if you can help spread the word about this, it'd be great. But there are tons of businesses out there that are small businesses. They run open nodes, or they run it on web, which is not secure, which we'll talk about, and they run credit cards over the internet. So some of the credit card terminals use the phone lines still, so those are separate and they're okay. But if they use a newer credit card terminal and they connect over the Ethernet network, and they're using an open network, they are in violation of PCI requirements, which this is beyond the scope of CCNA, just so you know. This is just my little soapbox for a second. This is the payment card groups, the Visa, MasterCard, American Express, Discover, all those cards. They banded together and they created this working group, and they create standards for security for credit card processing. If you're running an open node and you're doing credit card processing through the internet, you have to shut this off. You have to switch to a higher security level. You are in violation of PCI, which is tens of thousands of dollars or more in fines. You could be banned from using credit cards. It's a mess. You could be up for charges if there's breaches. You don't want to get anywhere near this. Stay away from open nodes unless you have a very locked off guest network. Remember, we're talking about VLANs. Make a separate VLAN that goes only to your firewall, to the internet. Make that your open node or something. Do not use open node otherwise. If you're in any sort of business situation, don't do it. There's also, now that I've scared you, there's also a shared key. So there's a shared key option. So this is a little bit better, which means there's some sort of password basically on the client and the access point configuration, and the client will have to have that shared key. So within that, there's a couple different versions. There's WEP, there's WPA, there's WPA2, and these are different levels of security that you have available to you. So this is WEP is the wired equivalent version, It's the original security spec. It really was known to not be the most secure even when it was released, and now can be cracked in 5 minutes. And if you don't believe me, go out on YouTube and take a look. It's very easy. And you can use that Kali Linux and Backtrack Linux and that to do it. So no big deal to crack WEP. Same with OpenNode. Do not use WEP if you're in this sort of situation. No, stay away. Use WPA, WPA2. So WPA is kind of the middleman here. It's based off of WEP in a way, but it has additional security features, like you can run a different encryption algorithm like AES/TCAP, which give you greater encryption, and WPA2 is the most secure, and that uses AES. I don't know why I can't write today. AES, and also has the option for 802.1x, which we're about to just talk about. So this method is the most secure. If you use WPA2, that's the preferred method of security for your wireless network, and 802.1x is the preferred method for authenticating and ensuring people are who they are supposed to be to get onto your network. But in order to do so, it's really more for environments that have a database of users. Like if you're running a domain or something like that, your guest access is probably not going to run through 802.1x. But if you have a number of employees or something like that, you definitely want to try to set up WPA2 and 802.1x. So 802.1x is your third option really for security, which is the preferred way. So 802.1x requires a username and password, and you can run that through to an upper level server such as Radius or LDAP or something like that. So you can check on those user databases which are tied into your environment's configuration and HR systems and all that stuff. This is used in larger businesses. As far as, and the last thing we'll go over is, if you want to get into this, actually before I go on, if you want to get into the security of wireless, there's great certifications out there to look into. There's specifically wireless certifications through Cisco and others. There's also vendor neutral certifications out there for it that go through some of this stuff in great detail. There's also Cisco-wise, it used to be the CCSP, and now it's the CCNP wireless or CCNP security. I forget what they changed it to, but they keep changing the name. Network, was it wireless security, something like that. So they have CCNP wireless now, right? And then they have CCSP for security with the firewalls, and so both of those really tie into this. The wireless side will take care of this, and then the security side will take care of stuff like that. If you want to get into wireless security, though, go into some of those further studies like NP security, wireless, and so on. There's a great number of certs that really dive into this. So the last thing we'll talk about for wireless access is there's two different ways to access these networks now that you've set all this stuff up. There's the passive client, and then there's the active. So passive client means the environment will broadcast the SSID beacon, and every so many seconds the beacon gets sent out, and when you go into like a laptop and you click on the little wireless icon and it says here's all the different wireless networks that are available, that's passive mode. So the client doesn't have to do anything to see the wireless network is there, because the environment is creating that SSID to be broadcast out and shared with everybody and say, hey, this is available for you to connect to. Active mode is the client needs it all configured. You need to input the SSID, you need to put in the security mode that you've chosen, you need to put in the passwords, you need to put all that stuff in there. and most likely the SSID is not broadcasted, which really is not a big security improvement, because if someone's sniffing the wireless area, they'll be able to tell that people are communicating on this SSID anyway. So it really doesn't offer any sort of security beyond maybe the local neighbor kid that's trying to find your network or something. It really doesn't do much. But that's why some of these security features like WPA2 and that are so important, because these other ideas that have been brought up in the past to try and improve security really don't do much. And going along with hidden SSID, there's also one called MAC filtering. So another option you can do for security, not just these encryption options, but you can make a list of different MAC address NICs that are allowed to access your network. And again, this is really just meant to keep the neighbor kids out of your network. Anyone can still take a look at what traffic is being sent and received and then spoof the MAC. So it really doesn't do much for you in a larger environment. If someone wants to get in, they will get in. So that's where the encryption levels really come in to be important, because if they're trying to get in, at least use the highest level of encryption that you can. Use an 802.1x backend for your database for people to authenticate, and you can prevent that sort of access. These other sorts of stopgap solutions really don't do much if someone's actually trying to get into your system.